Welcome to Probability Theory and Statistics. Today we are diving into measures of location. Imagine trying to describe the heights of 50 students to a friend. Reading a massive list of numbers is confusing and boring. Instead, we want a single powerful number that represents the typical student. This is exactly what measures of location do, and they are the absolute foundation of data analysis. Let us get started. Now that we know why we need a single representative number, let us define what it actually is. A measure of location is simply a mathematical way to find the center or the most representative value of a whole group of numbers. Think of it like finding the exact balancing point on a seesaw where all the weights are perfectly leveled. By finding this center point, we can summarize a massive amount of chaotic information into one easy-to-understand number, allowing us to make quick comparisons and informed decisions without getting lost in the raw data. Building on this idea of a balancing point, let us look at the most common measure of location, the mean. Most people in daily life just call this the average. To understand the mean intuitively, imagine you and 4 friends empty your pockets and put all your money into a single pile on a table. If you then divide that pile of money equally among all 5 of you, the amount each person gets is the mean. It is the value every piece of data would have if they all shared the total amount equally. Now that we understand the concept, let us see how to calculate it mathematically. The formula might look complex, but it simply says to add up all the individual values and divide that total sum by the number of values. The symbol x bar represents the sample mean. The Greek letter sigma is a mathematical command that means to add everything up. The variable xi represents each individual number, and n stands for the total number of items. If n increases while the total sum stays the same, the mean will decrease. Just like sharing a single pizza with more people means everyone gets a smaller slice. Before we move on, let us see this formula in action with a concrete example. Suppose a student takes 5 quizzes over the semester, scoring 6, 8, 7, 9, and 10 points. We want to find the mean quiz score to understand their overall performance. Our strategy is to first find the total sum of all the quiz scores by adding them together. We simply list each score and place an addition sign between them. Adding these up gives us a total of 40 points. We also note that the total number of quizzes, n, is 5. Continuing with our calculation, we now substitute our total sum of 40 and our count of 5 into the mean formula. We are essentially asking how to split 40 points equally into 5 identical buckets. Dividing 40 by 5 gives us exactly 8. This means that if the student had performed exactly the same on every single quiz, they would have scored an 8 each time. We can confidently say this student is performing at an 8 out of 10 level on average. So we have successfully calculated the mean, but it has a major weakness. It is easily pulled away from the true center by extreme values, which statisticians call outliers. Imagine 10 regular people are sitting in a coffee shop and suddenly a billionaire walks in. The mean wealth would make everyone look like a multi-millionaire, which is completely misleading. To fix this problem, we use another measure of location called the median. The median is simply the exact middle number when you line up all your data from smallest to largest. Let us visualize exactly how outliers affect these measures. Here we see a distribution graph with a long tail stretching to the right, representing those extreme outlier values. Notice the 3 vertical dashed lines? The mode sits at the very peak, representing the most common value. The median sits perfectly in the middle, splitting the area under the curve into 2 equal 50% halves. But look at the mean. It is pulled far to the right, dragged away from the typical values by that long tail of outliers. This diagram clearly shows why the median is a safer choice when extreme values are present. Now that we see why the median is useful, how do we actually find it? The most critical step is that you must first sort your data in ascending order, meaning from smallest to largest. If you skip this, your median will be completely wrong. If you have an odd number of data points, the median is simply the single number sitting right in the middle. If you have an even number of data points, there is no single middle number. So you find the two numbers in the exact center and calculate their mean by adding them together and dividing by 2. Let us see why the median is sometimes much better than the mean using a real-world scenario. Suppose 5 people work at a small startup. 4 regular employees earn 40,000, 42,000, 45,000, and $48,000. The founder pays themselves $500,000. We want to find the median salary. Our first approach is to ensure the salaries are listed in order from smallest to largest. We write them out as a mathematical set. Because we have 5 salaries, which is an odd number, we will simply pick the one that sits exactly in the middle. Continuing with our sorted list, we look for the middle position. We can see that there are 2 salaries below the middle position and 2 salaries above it. The middle position is perfectly balanced. The median salary is $45,000, represented by the symbol X tilde. Notice how accurately this represents the typical worker at this company. If we had calculated the mean instead, the average salary would be $1,35,000, which is completely false for almost everyone working there. The median ignores the founder's massive outlier salary. We have covered the mean and the median, which brings us to the third common measure of location, the mode. The mode is simply the value that appears most frequently in a dataset. Think about a shoe store trying to decide which shoe size to keep in stock. They do not care about the mean shoe size because the average of a size 7 and a size 9 is an 8, but maybe nobody actually wears an 8 in that specific style. Instead, they want to know the mode, the specific shoe size requested most often. It is the most popular data point in the group. Sometimes, finding just the center is not enough. We want to know about other specific locations in the data. This brings us to percentiles and quartiles. A percentile is a value below which a certain percentage of the data falls. It is like slicing a giant cake into 100 equal pieces to see exactly where you stand compared to everyone else. Quartiles are just special percentiles that slice the data into 4 equal quarters, like cutting a pizza into 4 massive slices. These measures help us understand the spread and location of data points across the entire range. Now that we have learned these measures, let us look at how they are used in the real world. Measures of location are the absolute foundation of all data analysis. Governments use the median income to understand the true economic health of their citizens, avoiding the distortion caused by billionaires. Engineers use the mean time between failures to predict when a machine part will break, ensuring airplanes remain safe. Retailers use the mode to stock their shelves with the products people actually want to buy. They distill millions of chaotic data points into powerful truths. Let us summarize what we have learned today. Measures of location give us the typical value of a data set, so we can understand it quickly. The mean shares the total equally among all members, providing a mathematical balancing point. The median finds the exact middle to ignore extreme outliers, protecting our analysis from being skewed. Finally, the mode identifies the most popular item, which is perfect for categories and inventory. Choosing the right measure depends entirely on the shape of your data and the specific question you are trying to answer. You now have the tools to find the center of any data set.